All right, in our last video, we looked at how to graph a cosine function, and we compared it to our sine function that we looked at in class. So in this video, we're going to look at how to transform the sine and the cosine function. And to do that, I want you to memorize 5 points. So the first one is f at 0. So when x is 0, or when we're at 0 degrees, sine of 0 degrees is 0, and cosine of 0 degrees is 1. Sine of 90 is going to be 1, and cos of 90 is 0. Sine of 180, we're back at 0, and then cos of 180, we're at negative 1. And then the sine of 270, we're all the way to negative 1 now. And for cosine function, we're at 0. And then sine of 360, we've gone all the way around the circle, we're back at 0. And the cosine of 360, we've gone all the way back to 1. So with these 5 points, we're able to transform any sine or cosine function. So the first transformation we're going to look at is when we have a vertical stretch. So this is whenever you have a number in front of your sine function or a number in front of your cosine function. What this changes, in Unit 1 we actually looked at how this was a vertical stretch. It's the same thing in this unit as well, but we call it a change of amplitude. So we're still going to call it a vertical stretch, but we're just going to pay attention to the fact that this is actually changing the amplitude of our sine and cosine functions. So we're going to start with those 5 basic points, 0 at 90, at 180, at 270, and at 360. And we're going to graph sine of 2 theta in blue, and then we're going to do sine of half theta in green. So let's do sine of 2 theta. I'm taking all of my y values and I'm just going to multiply them by 2. So 0 times 2 is still 0. 1 times 2 becomes 2. 0 times 2 is still 0. At 270, I'm at negative 1. Negative 1 times 2 is negative 2. And then I'm back to 0. 0 times 2 is 0. So now that I have my 5 points, I can graph my curve. So I'm just graphing the curve to reach those points. And here we can see that the amplitude of this new function, this vertically stretched function, is now at 2 instead of where it was before. It was just 1. So my amplitude before was 1 and now it's 2. All right, so let's do sine of half theta. So now I'm taking all of those same values and I am multiplying by them by a half instead of by 2. So 0 times a half is still 0. 1 times a half becomes a half. 0 times a half is 0. Negative 1 times a half is negative a half. And then 0 times a half is also still 0. So now we can see that I have that same sine function, only it's like it's been squished. So this is actually a vertical compression, right? And my amplitude is now at a half. So it's very similar for the cosine function. Once again, I start with those 5 main points and I just stretch them up. I stretch the y values up to wherever the new amplitude is. So my first point is at 0, at 90, at 180, at 270, and then at 360. So all of those y values are just getting multiplied by 2. And then I can draw my curve going between them. And there we have 2 cos theta with a new amplitude of 2 instead of 1. And then next, let's do half cos theta. So 1 times a half is going to be a half. 0, negative a half, 0, and then positive a half. So just like with the sine functions, I'm just drawing my curves between those points. And it's okay that it's not perfect. We try to make them as smooth as possible, really, but it's okay if your drawing isn't perfect. The only thing I want you to watch out for is make sure that you're not just drawing like a zigzag like that, right? That is definitely not a sine function. At least try to get your curves nice and rounded. Oh. Right? So at least try to get those curves as smooth as you can. I know that, you know, when we're in a hurry and we're writing a test, maybe you'll want to do this, but please don't do that, because that is actually a different function. That is a triangle wave. That is not a sine wave. They're different. So please do not do that. At least try to show that you know that this is going to be a smooth curve. Okay, so next let's look at what happens when we have a negative sign in front. So it's kind of like I'm multiplying all my y values. It's like I'm multiplying them by -1 now instead of by a positive number. So once again, I start at those 5 basic points. And now I'm just going to multiply everything by -1. So 0 times -1 is still 0. 1 times -1 is -1. 0 times -1 is still 0. -1 times -1 is +1. And then I end up at 0 again. So when I'm drawing my curve, I end up with a curve that just, you know, looks like it's the reflection of the first curve, right? So we call this a reflection in the x-axis because it's kind of like my x-axis over here was a mirror, and it's like it's just reflecting everything, as if it was, you know, as if these were hills on a lake, and the lake is reflecting it as well. So let's look at what happens when we have a number and a negative sign. So this is -2 cos theta. I'm just multiplying everything by -2 over here. So now I have a curve that's coming up and then going down. And if I needed to draw more points to get that happening, I could continue the curve as well. Right? Okay, so let's review. The absolute value of A, so that means the positive or the negative of A, is called our amplitude, right? So here we can see that even though there's a -2 in front of our function, our amplitude is still going to be +2. So whenever we're asked about the amplitude, we always take the positive value of that number. So the absolute value of the number in front of our function is the amplitude. If A was bigger than 1, then we call it a vertical stretch because our function is getting stretched out. If A is between 0 and 1, if the absolute value of A is between 0 and 1, so that means it's a fraction or it's a decimal number, then there is a vertical compression. So it's like our graph is being squished. And then finally, if A was negative, then we have a reflection in the x-axis.